Hello students, welcome to this session. I am Amirash and I teach you science on this amazing platform of the year world. Welcome to the second session of your CBSE 10 Physics, Chapter 12 Electricity, Session number 2 with me. We've already covered one lesson of this chapter. In case you've missed that, you may attend that. The link of the same will be provided in the description box and you can even check out the video through our playlist. So today we have the second lesson of your amazing chapter electricity. In the first lesson, I taught you about two things. Number one, I talked about the electric charge and current. Number two, I talked about electric potential and the potential difference. In case you have any doubt related to these topics, you may post them in the comment section. I will take your doubts. So today, what is our agenda? What are we gonna do? First of all, we'll be clarifying with Ohm's law what is Ohm's law exactly, and all the doubts which you had related to Ohm's law, that will be sorted. Then we'll be cracking resistance, which is an important aspect from your CBSE 10 board's perspective. And the third, we'll be doing numericals. In the next session, if I tell you, we will be doing resistivity. We'll be doing resistivity. My God, 1 second. Yeah. And the second thing, we'll be doing factors affecting resistance. Got it, bacha? So we will be doing these two important topics along with some of the good level questions. So are we ready to begin? If in case, then click on the like button right away. I need not have to say it in every session. Like the video, you should be able to like it. Okay, so let's get started, people, without wasting even a single minute. Okay, now first of all, I would like to take you to the world of SST for some time. Just focus, okay? Just focus over here, attention over here. So people, tell me, do you know about air pressure? Air pressure, or I would say air flow. Do you have any idea about this? Do you people know about this much SST? See, whenever we have airflow, whenever the air is going to flow, it is always going to flow from a region of high pressure to a region of low pressure. Okay, people, it is going to flow from a region of high pressure, बहुत ज़्यादा pressure, to a region of low pressure, जहाँ pressure बहुत कम है. And why does this happen? Because of the uneven heating of Earth. At some parts, let me change my orientation so that I can explain. Okay, now understand, suppose I have this is my Earth. So from the sun, okay, let me draw the sun with yellow color. Or 1 minute, let me make it once more. This is your sun, let's say. Okay, this is your sun and this is, okay, blue color, and this is your Earth. So we know that it is bulged at the center and flattened at the ends. So at the equator, the direct rays of the sun are going to fall, whereas poles are going to receive indirect rays from the sun, and this causes uneven heating. This is the reason for uneven heating, which creates low pressure and high pressure differences. But why am I telling you this? Let me tell you. Okay, now let me tell you why am I telling you about high pressure and low pressure. Now we know that airflow happens due to air pressure difference. Wind blows from a region of a higher pressure to a region of lower pressure to equal out the differences, so that no differences are going to be left and everything is going to be balanced. Okay, everything should be balanced. Like we balance chemical equations, in the same manner we are going to balance this. So people, just understand, from the region of high pressure to the region of low pressure. Okay, now with this, tell me a question. What happens to the airflow if the air pressure difference in the atmosphere increases? Tell me, think and let me know. If in case the air pressure difference, if it is going to be more, from high pressure to low pressure, we know it is going to flow. So if the difference is more, then what is going to happen? Definitely the airflow is going to increase. If the pressure is more, then airflow is going to increase. This is a very, very obvious thing. But then you'll ask that why are you telling this in physics? Because Ohm's law is connected with this difference only. Okay, one more question. There is an air pressure difference of 40 Pascal and 100 Pascal. In which scenario the airflow will be more? In 40 Pascal, 100 Pascal, both or nothing is going to happen. If the difference is more, then airflow will be more. So the answer is going to be 100 Pascal. So by this you are able to conclude, what are you able to conclude exactly? I am able to conclude that if air pressure difference is more, if it increases, then airflow increases. There is more amount of airflow. This I am able to conclude by this particular question first. Okay, first this particular question, then from high pressure to low pressure. This also I am able to conclude. Now try to understand that in terms of your electric circuits. How are we gonna apply this? Similarly, let's talk about electric circuits. Now in electric circuits, how is it going to be there? Now tell me the answer of this question. See, if I have two batteries of electric potential difference, potential difference, the same thing, do not get confused. See, one is 6 volt and the other is 10 volt. So in which of them the current will flow more? In 6 volt battery or 10 volt battery? It is connected to your air pressure difference. In this we saw that if it was 100 Pascal, if the pressure was more, then there was more air flow. In the same manner, if the potential difference is more, then more current will flow. So your answer is going to be 10 volt. In a 10 volt battery, more current is going to flow as compared to a 6 volt battery. But why this happens and what do you conclude? What do you understand by this observation? Let's try to understand. Now, first of all, we will be understanding about the conclusion, that what do you conclude? What do we exactly learn through this? Okay, now first thing, the first point that you learn is as the potential difference across a circuit increases, current also increases and vice versa. What do I understand by vice versa in this case? I understand by vice versa that first, if potential difference will be more, current will be more. If current will be more, potential difference will be more. This is vice versa. This is very, very important. It means if in a circuit a potential difference will increase, current will automatically increase. And if in a circuit current will increase, potential difference will also automatically increase. It means we are able to see that there is one or the other relationship between this. What is this relationship? This is the direct proportionality. So we can understand that the current flow in a circuit is directly proportional to the applied potential difference. Okay, now understand once. See, current flow in any circuit. What is your current? Current is I. And what is your potential difference? Your potential difference is V. So what is the symbol of direct proportionality? I is directly proportional to V, or V is directly proportional to I. This is your funda. And this is your Ohm's law. Got it? I think I've made it easy peasy lemon squeezy. Now by this you're able to understand one thing, that the current flow in a circuit is directly proportional to the applied potential difference. Now if I'm talking about the mathematical formula, then it is V is directly proportional to I, or I is directly proportional to V. But then how do we turn this proportionality relation into an equation? Because in physics, we tend to convert everything into an equation. So how do I do this? Understand. See, before that, I would like to explain you something, that whenever we want to remove this proportionality sign, we add a constant, and here the constant is R. What is R over here? R in this case is your resistance. I will talk about it, please don't get confused first thing. So V is equals to IR. Like if you take any example, if you want to remove the proportionality sign, you always have to add any constant. So by this you can see one thing, that if anything, let's say if A is directly proportional to B, so A will be equals to XB equals to, it means there is some constant into the number. This is X, let it be like this, X into B. Correct? Same here. We get V is equals to IR. This becomes our formula. Okay. Now see, we add a constant, and the constant in this case is going to be your resistance. What is resistance? By the name also you are able to understand, it is going to resist something. Okay, it is going to oppose something. In this particular case, it is going to oppose the flow of current. Now let me tell you one thing, that how did we get this resistance? For that I will have to change my orientation. Okay, now just understand over here that why did we take this only? So we got the formula. Let's say if it wouldn't be resistance, let's say if it would be X, any variable X, then what is the relationship over here? That V is directly proportional to I, one relationship. Now according to the formula, if we wanted to find out the value of X, if we want, then what would that be? X would be equals to, just shift V this side, then you'll get V upon I. Correct? Or just shift X that side, so we will come here, this is the numerator, it will go in denominator, so V X will be equals to V upon I. So with this I am able to understand that this X would be inversely proportional to the current, to the flow of current, which means that if the current would increase, then this value would decrease. If current would decrease, then this value would increase. In the same manner, if this X, this is any value, if this would increase, the flow of current would minimize. If this would increase, if this would decrease, the flow of current would be maximized. What am I trying to say? See, now just focus over here. Only one thing I would like to tell you. This X is inversely, one second. Is inversely proportional to the current, that is your I. It means if this X is going to increase, rate of flow of charge will decrease, that is your current. If this X would decrease, your current would increase. It means it is opposing the current. If this is increasing, current is decreasing. It means this is your resistance. In this manner we got resistance. And that is nothing but resistance. Resistance is only going to oppose your current. So in this manner we get the resistance. I hope it was helpful, this kind of an explanation about resistance. Okay. Now see, we are able to understand if V is equals to IR, then R will be equals to V upon I. So R is directly proportional to V, R is inversely proportional to I. That is current. Clear? Okay. Now this is something which I explained you just now. You can read, and since they are inversely proportional. Got it? Now see, resistance is the opposition to the flow of current. It means it is the it opposes the flow of current. Got it? And what is the SI unit of resistance? It is ohm, and we represent ohm because And what is Ohm's law? I have told you before only, okay, that the current flow which is flowing through any conductor is directly proportional to the potential difference applied across its ends. Okay, this is your Ohm's law, and we know that Ohm contributed a lot, and to honor him we have kept the SI unit of resistance as Ohm, and it is represented by the Greek symbol omega. Okay, so whenever you come across Ohm word, you will get this symbol. Do not get confused. What is this now? This is the symbol of Ohm. Now let's solve some questions. First question is, potential difference of 10 volt is applied across a bulb. The current flowing through the bulb is 5 amperes. What is the resistance given by the bulb? This is a very easy question. See, potential difference is given to you 10 volt. Okay, current is given to you 5 ampere. I is given to you 5 ampere. What you have to find the resistance. Please write like this so that it will be helpful for you. This is your table of information. Okay, now apply the formula. First you write according to Ohm's law. I'm not writing that. V is equals to IR. Okay, just now I taught you. So we have to find R. R will be equals to V upon I. Just now we have done. So if I apply the values, V is given to you, just substitute 10, I is given to you 5, so your resistance is going to be 2 ohm. Simple. Resistance will be 2 ohm. So what is the answer? 2 ohm. Got it? Let's move to the next question. If the resistance of an electric ion is 48 ohm, resistance is given to you 48 ohm. Okay, now, and an electric current of 5 amperes is flowing through it, what will be the potential difference between two terminals of the electric ion? Don't get confused by the language, just take out the values. Current is given to you 5 amperes. Okay, now, and what are they asking? What will be the potential difference between the two terminals? Because we know that potential difference is what? Tell me in the chat box. I've already explained you. Okay. Yes, the work done for moving a unit positive charge. Okay, this is your potential difference. So from one terminal to the other terminal, let's say this is A and B. So that what is going to be that potential difference if we have these values? So we have to find out V. Easy now. Now let's solve it. So your answer is going to be according to Ohm's law, V is equals to IR. Simple substitute. I is given to you 5, R is given to you 48, so you will get 0 and 1 carry, so you are going to get 240 volt. Is this question clear? If yes, then click on the subscribe button and hit the like button so that we will get the appreciation. Okay, so your answer becomes 240 volt. Please remember the SI units, not get confused. Now the last question for today, it is going to be your homework question. You need to let me know in the comment section. The current passing through a resistor in a circuit is 0.01 amperes. I think this is not visible to you. Is that so? Let me just show you the question once. See, the current passing through a resistor in a circuit is 0.01 ampere when the voltage across, what is voltage? See, voltage is nothing but your potential difference. Never get confused. This is nothing but your potential difference. Okay, same resistor is 5 volt. What current passes through the resistor when the voltage across it is a 7.5 volt? You need to let me know this particular answer in the comment section. I will be waiting for your response. Let me just tell you a hint what you're going to do. First of all, it is given to you, the current is given to you. What is it? See, current is given to you, I think 0.01 amperes. Okay, and the voltage is given to you 5 volt. So first you are going to find the resistance. Okay, first you will find the resistance for this very case, for this particular case, and after that the current passes. Then you are going to multiply this resistance into the voltage. Into which voltage am I talking about? I am talking about this particular voltage, that is your uh, yes, 7.5 volt. So you will get your current dash amperes. Now I have given you the hint. I think I've told you the answer only, so you need to let me know in the comment section. This is your homework question. Got it, everyone? I hope you are going to do, and I will be taking the names of homework rockers in the doubts plus mentee session. So do not forget to write the answers in the comment section. With this, we have finished with today's session. I hope you liked. In the next session, we'll be doing factors affecting resistance as well as resistivity. I hope resistance is clear and Ohm's law is also clear. Now it's time to say goodbye. Bye bye. Take care of yourselves and stay healthy.